Hi, I'm Adolph Oliver, and this is the video about adding and subtracting polynomials. Now, we actually know all these methods already. Adding and subtracting polynomials is just like collecting like terms. So, let's take a look at an example here. We have two polynomials. These are actually two binomials. This first one has a plus in front, so it's being added. The second one has a minus in front, so it's being subtracted. Now, if both of these guys had been pluses, then nobody'd be changing, and we really wouldn't need to rewrite it. But since there's at least one of them that has a minus in front, then the safest thing to do by far is to rewrite the whole thing, distributing the signs in. So once again, we distribute the plus in. Plus doesn't cause any changes to occur, so we end up with the plus 3x. I'll put a plus in front to rub that in, minus 7. But distributing the minus in changes the signs on everybody. So we got minus 5x, plus 5x became minus 5x, plus 2 becomes minus 2. Remember that you have to distribute the signs into everybody inside. Well, now, let's take a look and see what we have in the way of like terms. Here are two terms that have x to the first power, and the guys I often underlined here are just plain numbers. So we can turn around and say, okay, let's combine these. Now, we should write them in descending order. Highest power of x first, next highest plain number at the end. Well, there's only one power of x here, so we write that first. Plus 3x minus 5x, negative wins by 2, so negative 2x, and then negative 7 and negative 2 combined, well, they're both negative. There's no positive here, so the total negative is 9. Well, this is the process we're going to be using as we go on here. Again, it's some simple things that we've already done. Now, next up here, let's take a look at some examples. And here we have, to begin with, a couple of binomials here. Notice there's no sign in front of the first guy here, so we assume that that's positive. There's a plus sign in front of the second guy also. Plus signs, again, when you distribute them in, don't cause any changes. So what we're going to have is exactly what we see here, so there's no need to really rewrite it. Here are going to be the x squared terms, and the guys I often underlined here are the x to the first power terms. Okay, well, let's see what we've got here. Negative 2x squared plus 3x squared. Positive wins just by 1, so I could write plus 1x squared, or just simply x squared. You could put the plus 1 if you want, but folks will assume that. Okay, the guys that are x to the first power, okay, plus 4 plus 2 more, that's plus a total of 6x. Now notice, we did write this in descending order. Highest power of x first, x to the first power, there's nothing else to do, so there we are. Okay, next one coming up, we've got one of them that's being subtracted. The guy in front, we don't see a sign, so we assume him to be positive. So if there's at least one of the polynomials that's being subtracted, we better go through and distribute our signs in to make sure we've got all the correct terms. Well, the plus here in front doesn't change anybody, so I got plus 3a plus 6. But distributing the minus in is going to cause everybody inside to change, so minus 4 becomes plus 4, and plus 3a becomes minus 3a. Okay, well, let's see, minus went to plus, plus went to minus, so I did change both of those. So it looks good. Okay, we're ready to come up with the final answer. Here's our a's to the first power, and then we'll do the plain numbers again, writing it in descending order. Well, look what happens here. Plus 3a minus 3a, these guys zero each other out, don't they? And that will sometimes happen. that some of your terms will zero out. The constant doesn't. We've got plus 6 plus 4, so we just end up here with 10. Okay, looking a little further down here, a little bit more going on. We've got 3 binomials here. The last 2 are being subtracted. The first one we don't see a sign, so we assume that to be positive. Well, since there's at least 1, and actually 2 here, that have things changing, best to rewrite it and not try and do this in your head. So here we go. The plus going in is not going to change anybody. So I got plus 3y to the 4th plus 8y squared. But the minus is going to change everybody in the middle polynomial here. So minus 2y becomes positive 2y. Plus 2y squared becomes minus 2y squared. Now let's double check that we changed these guys. Minus went to plus, that changed. Plus went to minus. Okay, we changed everybody. One last guy, same thing. The minus is going to change everybody. So this was officially a plus 8y squared inside the parents. So now we change it, becomes negative 8y squared. And here, the minus 3 becomes positive 3y to the 4th. Now let's double check that we changed everybody. The 8 was plus inside, it came out minus. The 3 was minus inside, it came out plus. Okay, that looks real good. Now let's see what happens here. We've got, let's see, y to the 4th, 2 of them. There's a bunch of y squared, so I'll give them double underlines here. Okay, and right here. Okay. Well now, put them in order. Highest power first. Y to the 4th is highest. Plus 3 here, plus another 3. That's going to be 6. Y to the 4th. You could put the plus in front if you wanted, but if you left it off, folks would assume that. Okay, so that's the y to the 4th. We've done those. The y squared. So look at this. Plus 8y squared and minus 8y squared. These two guys are going to knock each other out. So the only y squared that's left over here, minus 2y squared. Okay, well, the only thing left to write down is plus 2y. So there it is, and I do have it in descending order of the powers. Okay, well, you're not always going to get nice whole numbers. You're going to get decimals and fractions here. So let's take a look at some examples where we see this going on. Okay, a couple of binomials up here. We got decimals in them. Again, the guy in front, we don't see a sign, so we assume it to be plus. There is one with a minus here. So what we better do is go through and rewrite everybody. The plus here doesn't change anybody inside here. So this is plus 2.55 x squared plus 4.555 z. Oh, I should say these are z's, not x's. So, okay, 2.55 z squared, and this is just 4.555 z. Okay, now, distributing the minus in is going to change everybody. So this plus 0.2z becomes minus 0.2z. This minus 0.2z to the 4th becomes plus 0.2z to the 4th. Now let's make sure that we change the signs of these guys in here. This was officially a plus, became a minus. Okay, I changed that. Minus became plus, so it looks like I did that part correctly. Okay, what's the highest power we see anywhere here? This one right here. Z to the 4th, this is z squared. The other guys are only z to the 1st. So this becomes 0.2. Again, you could put the plus in front if you wanted. z to the 4th. And that takes care of that guy. The next one here are z squared. Well, that's nothing to combine it with, so just write it down the way it is. 2.55 z squared. Now, these guys, we got plus 4.555z minus 0.2z. Well, this 0.2 is going to subtract from the tens place. Positive is still going to win here by a long shot, so it's going to be 4 point, but now when we subtract the 2 from the tenths, this will be 0.3, and then 55z. Okay, well, there we are. We combined like terms again, and we wrote it in descending order. Now, fractions. Okay, again, remember, to add and subtract fractions, we've got to have a common denominator. But first, as is not uncommon in what we've had, we got at least one guy here that's being subtracted. The guy in front, you don't see a sign, so we assume plus. So rewrite everything. Distributing the plus in doesn't change anything. I'll put a plus 8/3 here to really rub that in. And then the minus 7/2 x to the 4th. Now, the minus being distributed in is going to change the signs. So the plus 2x becomes minus 2x, and the minus 4/3 becomes positive 4/3, and x to the 4th. Now, let's make sure we change the signs. This was plus, became minus. This is minus, became plus. Okay, that looks real good. Now, let's see. What's the highest power we have here? Highest power here turns out to be the x to the 4th. Huh? So these are the first guys I'm going to write down in the answer. Well, here's the first problem I got. I don't have a common denominator. So over on the side here, I got a little bit of room. Let's work on this. Here's the negative 7/2 coefficient of this x to the 4th here. And here's the plus 4/3 coefficient of the other x to the 4th. Well, the LCD is 6. So what I'm going to have to do, okay, LCD equals 6 here. I've got to multiply top and bottom of this guy by 3 and top and bottom of this guy by 2. Now remember, 2 over 2 equals 1. You never change the value of anything when you multiply by 1. You change what it looks like, but you don't change its value, and the same thing with the 3 over 3. So what do we have here? Minus 7 times 3, which is minus 21 over 6. And then this is plus 4 times 2 is 8 over 6. Okay, well, not too hard to see here that who's going to win is going to be the negative. Negative 21 plus 8, I think we end up with negative 13/6. Okay, well, remember, what we were doing with this was we were combining the coefficients of the x to the 4th. We got a common denominator, and we combine that. So we end up with negative 13/6, and that's x to the 4th. So we're able to combine both of these guys. Now, the x to the first power, I've got plus 8/3 here and 2 over x. Well, the first thing I'm going to do is make a fraction by putting a 1 underneath this. And then what we're going to have to do is combine the coefficients. So over again here, I got a little bit of room. Let's write this down. Plus 8/3, that's the coefficient of the first x, minus 2 over 1, that's the coefficient of the second x right here. Well, the LCD is 3, and one of the guys is already at it. So the only thing we have to do is multiply the second guy by 3 over 3. There he is. And so I end up with plus 8/3 minus 2 times 3 is 6 over 3. Now 6 divided by 3 is still 2, so I know I'm right there. So now combining this out, I've got 8/3 minus 6/3. Well, 8 minus 6 is 2, so positive 2/3. Okay, that's going to be the coefficient of my x. So positive 2/3 x. Well, took a little bit of basic math work over here in the side to be able to convert those coefficients to common denominators. And of course, the LCD is what we want so that we can turn around then and write the final answer. Now, make sure that these fractions cannot be reduced. Remember, there's a standing rule in math here. Any fractions in final answers should be reduced, but these guys can't, so that's as far as we can go. Okay, one last one to look at here. These are a couple of 4-term polynomials. No sign in front of the first guy, so we assume plus. The second guy is a plus, so there's nobody that's being subtracted. So there's no changes going on, so there's no need to rewrite these guys. Let's just put them together in the final answer here. And again, we'll write it in descending order. The highest power I see in each one of these guys is n to the 4th here. So, okay, here are the two n to the 4ths. I got minus 4 here and minus 2 more. That's a total of minus 6 n to the 4th. Okay, cross out the guys we've done. Okay, n to the 3rd. Okay, I'll underline them here. Okay, minus 5 n to the 3rd plus 1 n to the 3rd. So that's minus 4 n to the 3rd. Notice I'm going in descending order here. Okay, next the n squareds. Okay, these guys. Plus 3 here, plus 2 more. That's plus 5 n squared. Okay, we've taken care of them. Now, there's no n to the first power here. The only thing that's left are plain numbers. So, okay, this is officially a plus 2. And then minus 4. Well, negative wins by 2. So there we are. So since nobody is being subtracted, there was a plus in front of both of these polynomials and parents. No real need to rewrite it. But whenever you have a case up here where you have at least one of the guys that has a minus, be sure you rewrite everybody.